Welcome back. It is now time for the ideal gas law. So if you've watched the other videos, we had Boyle's law, Charles' law, Avogadro's law, and now the ideal gas law. This is kind of the big one. This will put all the other gas laws together to give you one overall gas law. I'm going to take a little side trail, okay? But maybe write this one down because it is interesting and hopefully helps you a little bit. I don't know how much attention you've been paying to the last three gas laws we looked at, but if you write them all next to each other, so if you take Boyle's law, boys play video games, so PV, P1 V1 is equal to P2 V2. And then Charles' law, Charlie Brown is a TV show, T1 over V1 is equal to T2 over V2. And then you have Avogadro's law. Avocados are not vegetables is a little phrase. So you have N1 over V1 is equal to N2 over V2. Do you see something in common with all of those gas laws? Hopefully yes. They all have a common factor, and that is this V, volume. They all have volume. You actually can combine all of them together. You can put those three gas laws into one gas law because it's like all of them having the same X in math or something like that. You can put it all together. So I want you to pause this here, take a couple of minutes, talk to your neighbor, think it out, work with it, at your table there. Can you combine all of them? Because I know that, well, really all of you are smart enough to do this, okay? See what you come up with. Take a minute, pause. Can you combine all of these into one gas law? All right, I hope you maybe enjoyed that a little bit. It's actually kind of fun. I don't know if you think it's fun. I think it's fun to mess around with. If you put all these V's together, these two are on the bottom, and then this one's on the side. Essentially, you'll end up kind of flipping these over. And you come up with this. So if these flip, you kind of rearrange a bunch of things. You get P1 V1 over, because see how N and T are on the same side, they're on the opposite side of V, over N1 T1 is equal to P2 V2 over N2 T2. Did anyone come up with that? I don't know if you did or you didn't. If you didn't, it's okay. But that's actually all of those gas laws put together. Because when you're working with a gas, sometimes it's not just two factors that are going to change. What if, you increase pressure, you push on something, and then you put it into a smaller volume and it gets heated up, like the temperature increases. What would that do to your gas? What would it do if more than two factors change? There's got to be a way to calculate that. And turns out there is. Now this is quite bulky to use. And so the ideal gas law is based on this sort of idea, the idea that all four factors, P, V, T, N, okay, pressure, volume, temperature, number of moles, all four are going to come together into one law. And so when you do that, it's like you put this equal to a constant, all right? So you get P times V over N times 2 is equal to a constant, and then you can essentially rearrange that just a little bit. The format I need you to know is this one. Ideal gas law, PV is equal to nRT. PV is equal to nRT. PV is equal to nRT. I'm gonna put a star. You wanna memorize that, okay? You wanna know that. Actually, we're gonna use it so much, you probably gonna memorize this without even having to try. Okay, some of these factors you should know. Let's go ahead and make a little key over here. P, that is going to be pressure. Probably knew that. That should be in liters. Whoopie, a little off the page. Let's zoom out a smidge. V is volume. Whoa, I just messed that up, didn't I? Back up. Pressure is not in liters. Liters. Talking and looking at too many things. Pressure is in ATM. Sorry about that. Just erase that. Pressure is in ATM. Volume is in liters. is number of moles. So that is just in moles. R, we're gonna get to in a second. T is your temperature. You do want to make sure that temperature is in Kelvin, just like you did for Charles' law. Temperature cannot be in Celsius because Celsius is not an absolute scale. So those ones you kind of already know, you're familiar with: pressure, volume, moles, temperature. What about this R? What is R? R is a constant. And I'm actually gonna write it over here just to have a little bit more room, okay? R is known as the universal gas constant. That is R. So why is it R? I honestly have no idea. Because K was already taken and C was already taken, and so we made it R, as they love to do. Universal gas constant, and I'm gonna have a number for this, and I want you to go ahead and memorize this number. The number is 0.0821. I also want you to memorize the units, which are a little weird, but I'm going to explain it. Liters times, that's the raised dot, atmospheres over moles times Kelvin. So R is equal to 0.0821 liters, atmospheres, moles, Kelvin. Just say it a couple times, okay? You're going to have to memorize this as well. R is equal to 0.0821 liters, atmospheres, moles, Kelvin. R is equal to 0.0821 liters, atmospheres, moles, Kelvin. All right, say it a couple times, get it kind of in your memory, and as you use it, hopefully it will stick. What is up with these funky units? Why are they there? All right, basically, this number is here to make the math work out. And it's set in some of our most common units for chemistry. So pressure in atmospheres, volume in liters, moles or moles, temperature in Kelvin. So you see that, liters, atmospheres, moles, and Kelvin. It matches. What this does mean is anytime you're using the ideal gas law, all units must match R. Okay, all units must match R. What do I mean? I mean, if you have an example problem and they give you volume in milliliters, that doesn't match. You're not gonna be able to use this number. You're gonna need to convert from milliliters to liters and then plug it in. If your pressure is in mmHg instead of ATM, you're gonna need to convert first and then plug in, and temperature. And I will say temperature is almost always given in Celsius because that's what your thermometer measures. And then you just have to go ahead and convert it to Kelvin. Okay, if there's any of those unit conversions you're not super familiar with or you've forgotten, this is a really great time to brush up on them and make sure you're doing okay. All right, big idea. This gas law is the ideal. It's gonna put together all the other gas laws into one. And it is only for one gas. You notice there's no ones and twos. This is just one gas under one set of conditions. Imagine a balloon or like one of those pressurized steel tubes that you would use maybe if you're a diver and you have a gas tank, or maybe if you have a gas tank at your house that you use for fuel or something like that. And that's gonna have a pressure, a volume, a number of moles, and a temperature. And then R. FYI, there are different R values. There are different R's. This is the one we're gonna use. This is the one I want you to memorize. There are different numbers. Why? The different numbers come with different units. So if, for instance, you wanted this to be in milliliters instead of liters, or you can't do Celsius, but mmHg instead of atmospheres, then this number would change. So there's two approaches here. The first approach is to memorize a whole bunch of different R's and a whole bunch of different units, and then pick the R that matches your units. I find that a little bit obnoxious, and it's a lot of memory. So instead, I memorize one number with one set of units, and I'm gonna convert whatever I'm given to match. Okay? All right, let's work a problem. Okay, this says a car tire at 23 degrees Celsius has a volume of 25 liters and total pressure of 3.10 atm. How many moles of air are in the tire? So you're looking at your car tire, right? Not a very good car tire. Pretend that's a car tire. And it's your axle, whatever, it looks like a spider web now. So here's your tire, and that's gonna have one set of conditions. Nothing is changing. We're not adding air, we're not taking air out, anything like that. We're not heating it up, it's just existing, but we can use this to calculate. Let's figure out what we have. Degrees Celsius, what would that be? That should be temperature. And it tells you a volume of 25 liters. Okay, so that would be volume, that's V. Total pressure, this is a really nice equation, it's telling you everything. 3.18 atm is pressure, P. What is it asking for? How many moles? Moles are represented by the letter N. Okay, how many moles are in the tire? Let's go ahead and get our equation, and you know what equation to use by what you're given. I'm given a T, a V, an N, and a P. For 3 things, and I'm looking for the 4th one, that's ideal gas law. So PV is equal to nRT. We'll go ahead and plug. So P, just a game of finding them. P is right here, 3.18 atm. Volume, right here, 25.0 liters. I'm gonna write all my units in for this one to show you something. N is what I'm looking for, so I'm gonna go ahead and leave it N. R is, I'm not giving R. No, you're not. You're supposed to have it memorized, and you may not now, but look back in your notes, all right? R is 0.0821 liters atmospheres over moles Kelvin. I'm running out of room, so I'm gonna kind of squish that in there. And then temperature. Temperature is 23, but don't forget, you cannot keep that in Celsius, okay? Must be in Kelvin. Always, always, always in Kelvin for gas laws. So I'm going to take 23 plus 273. Okay, pause the video, plug and chug. That was plug. Now you chug in your calculator. Go ahead and solve for N. Don't forget to do this first, and then see what you get. All right, we do still have 3 sig figs, and maybe you say, miss, it does not 3 sig figs because that only has 2 sig figs. You are correct that 23 has 2 sig figs, but don't forget something, guys. You're adding. When you add 23 plus 273, you add them, you get 296. You're adding, you keep the least number of decimals, which in this case is 0 decimals. So in other words, the whole number. When you do that, you actually gain a significant figure. It does have 3 sig figs. Okay, that's a tricky thing with temperature because of the addition or subtraction, depending on which way you're going. You may change sig figs on that one, and that's okay. You just got to watch out for it. All right, so 3 sig figs. What you would do is take 3.18 times 25. To get N by itself, you divide this by all this business, it cancels. That means you divide this side by it as well. You end up dividing this side by 0.0821 times, make sure that the temperature bit goes in parentheses. That's what you'd plug into your calculator. Okay, that'll cancel this on this side. You should have N is equal to 3.27. What are my units? Go back and look. N, what's my units for N? N is moles, so the units are just good old moles. Okay, I want to show you something with this one here, and that would be why all these particular units. The units do work, okay, the units do work. Let's take a look at what happens with all of these units. So you end up with, up here, I'm just going to put units down, atmospheres times liters, divided by, R was liters, atmospheres over moles Kelvin, which is crazy, times, when you add this here, that becomes Kelvin. Those are my units. I know that's weird because it's a fraction on top of a fraction. When this all cancels down, what are you going to get? Well, when you are like dividing by a fraction, it's kind of like it flips and then you multiply by it. So what ends up happening is it's kind of like you have liters. No, I did that backwards, sorry. This flips. So you have moles times Kelvin over liters atmospheres. This flipped around. And then that gets multiplied by the top. Atmospheres times, I'm sorry, I cannot talk and write. I'm messing it up. Over Kelvin. Okay, so I flipped this one around and multiplied it by this, atmospheres, liters over Kelvin. When you do that, you see what happens. Atmospheres cancels, because it's top bottom. Liters cancels, because it's top bottom. What else cancels? That's right, Kelvin cancels. And ta-da, you are left with moles, which is in fact the unit that we want. Do you need to be able to do this? No, you do not need to be able to do that. If you want to, cool, it's gonna be good and helpful for you, and all of you are capable of it. You've got those math skills, I'm sure. But you don't need to. Just know that the reason these units are so weird, like liters, atmospheres, moles, Kelvin, what does that even mean? It's there to make all the other units work, okay? The easiest way I can say it is it's there to make the math work. All right, I'm gonna leave you with another example problem. This one will be on your worksheet for you. I'll just kind of get you started and then I'll leave you guys off, okay? What is the pressure in a 304 liter tank? I guess that's an air tank that contains 5.670 kilograms of helium at 25 degrees Celsius. I'm already seeing a couple issues with this, so let's talk through this and then I'll let you solve it. What is the pressure? So pressure, P, that's what you're solving for. In a 304 liter, what's that a unit of, guys? Liters are a unit of volume. Contains 5.670 kilograms. Kilograms. What's that? Well, it's actually a unit of mass, and mass is not in any of our problems in this chapter. But you know what is in our problems? Moles. You say, Miss, moles is my problem. Yeah, I know, I understand. But regardless, this is mass, kilograms. You're gonna need to convert that to grams. All right, so what you would do, remember stoichiometry? Oh no, not stoichiometry. Take kilograms, go ahead and convert to grams. So 1 kilogram on the bottom, and I'll let you fill that in. How many grams are in a kilogram? You should know that. If you don't, you Google it, ask your neighbor, review it, but you should know that conversion. And then you wanna go grams to moles. Class, how do you go from grams to moles? You should be saying periodic table right now. Yes, use your periodic table and plug in the atomic mass number for helium, He. All right, so you're gonna wanna convert this, but once you do that, that's gonna be N or moles. And then of course, the last number, 25 degrees Celsius, that would be temperature. Don't forget to convert this to Kelvin. All right, convert to K. Liters is fine, we can leave that alone. And this needs to get converted just like this. This needs to get converted to Kelvin. Say, Miss, how do you know what units? Like, how do you know what you're doing? You know what units you need based on R. R is 0.0821 liters, atmospheres, moles, Kelvin. Memorize this. That's gonna tell you, right? Liters, see liters? I match, I'm good. Atmospheres, that's pressure. Once I get pressure, it's gonna be in atmospheres. That will tell you what unit that is. Moles, see, that's why I had to convert. That's not moles, but I can get moles from it. So I gotta convert it to moles. Kelvin, that's not Kelvin, so you wanna convert it to Kelvin first. Okay, once you're done your conversions, PV equals nRT, plug and chug, plug that all in, and you are solving for pressure. All right, I'm not gonna do it for you. You guys figure that out and solve it. That's it, folks. Have a great day.